Okay, we're going to look at some of these 13.4 homework problems. The first one, they want you to write an integral over the region D, where D is a sphere of radius 6 centered at 0, 0, 0, using the order dy, dz, dx. So first they want us to do dy. So we want to take a typical point, x, y, z, in here, and we just want to think about taking lines parallel to the y-axis, and what do they do? Like, where do those lines run from? Well, typically they come in one side of the sphere and out the other side of the sphere. So all that you'd want to do is solve this for y. So you get 36 minus c squared minus x squared. Take the square root plus or minus, and they're going to go in the minus side and out the plus side of that. Then you're going to take y out of the equation, and we're just going to look at basically on the xz plane, because now we've dealt with y. We know what y does. We want to look down on the xz plane at the projection of this thing. And now we have a circle in the xz plane. And then next it tells me they want me to do dz. So what I will do then is take this equation and solve it for z. And I'm going to get 36 minus x squared. So basically, this is mislabeled on here. This should be a z, not a y. I'm going in the bottom of the circle, out the top. So this is going to be from minus the square root of 36 minus x squared to plus the square root of 36 minus x squared. Will be my bounds on that. And then the final thing that we're going to do, our last bound to set, we're just going on x. So now if you take out y, you take out z, you're down to x. So we went from 3 dimensions to 2 down to 1. Now in 1 dimension, what does x do? Well, it just runs from minus 6 to 6 all the time. Okay, so basically, we took the 3D, then we flattened down to just the center of this circle, the widest point, and we looked at what happened to z there, and then we flattened down to 1 dimension, and what does x do? Well, it goes, on this one, minus 6 to 6. So there's our bounds. Okay, now let's look at the next one. Computer's going very slow. Okay, the next one that we have, they want us to find the volume of this region over here. It's bounded by this plane in the front and then by the coordinate planes, so the xy, the xz, and the yz plane. And they have an order. They want us to do dz, dy, dx. So again, you think about taking points through, or lines in parallel to the z-axis through typical points, x, y, z. They're going to come in the bottom of this thing, which is z equals 0, the xy plane, and out the plane itself. All of those points will come out the plane itself. So you just solve this for z, and that will be your first bound right here. Then, now we've taken z out of it, we can just look down with the projection on the xy plane and see what's going on there. They want us to do y next. So if you took lines parallel to the y-axis, they're all going to come in at y equals 0. And they're all going to come out of this line right here. To get the equation of that line, you just take your equation of the plane and eliminate z. So you have 20x plus 5y is 20. Solve that thing for y, and that will be where all those points come out, or all those lines come out. And then finally, we've flattened it down, gotten rid of z. We've squished it back, gotten rid of y. We're just on the x-axis now, and on the x-axis we run 0 to 1. So that'll be our last bound over here. And then you actually have to integrate and solve. Okay, the last one we have is number 3. Use a triple integral to find the volume of the solid bounded below by the cone and bounded above by the sphere. And this one's going to be slightly more complicated than the others. They want us to start with z. So if you take a typical point, you're going to come in the cone and out the top of the sphere, so your bounds on that are going to be square root x squared plus y squared to x squared plus y squared plus z squared equals 800. You've got to solve that for z up there, and you know you want the positive part of that, right? So that's what's going to happen there. Then we're going to go to y. Well, when we take z out of this, we're just basically flattening down to, we're on this circle right here. So if we take z out of this thing, so yeah, if we take z out of this thing and we just look at the projection on the xy plane, we're going to look at this circle where they intersect. So if you plug x squared plus y squared in for z squared, you get 2x squared plus 2y squared is 800, or x squared plus y squared is 400. So that's the circle. And then we want to do that circle for y. So solve that circle for y and go from minus to plus, and that'll be your bounds there. And then for x, we are just looking at what happens on the x-axis. So we have the projection of the circle down here, and then we're just going, I think that turns out to be plus or minus 20. Our radius here is 20, so we're going to go from minus 20 to 20, and that's going to be what we end up integrating. So those are the bounds that we have. Right, so in the cone, out the sphere, then over the area of the circle, and then just on the x-axis from minus the radius to plus the radius. So not too bad. I will leave you to work out the other details. But that's pretty much how every single one of these works. You think about what happens with the typical point x, y, z, and sometimes you might have to break them up into multiple parts. Where lines go, and a lot of times we do the z direction first. And then you can squish down into the xy plane, the projection of the thing, and take either the y or the x lines and figure out what happens there. And then you squish down to one dimension, right? So 3 to 2 to 1. Your first one, a lot of times you'll have two variables in your bounds, then you'll have one variable in your bounds, then you'll have no variables, just constants in your bounds. Okay, hopefully this directly helps you complete 3 homework problems. I have a meeting to go to, so this is the end of the video.